Let's get started. It's 1 o'clock Central here in Illinois, and welcome everybody to this next episode of our HDF Clinic. I quickly checked, nobody has submitted any questions. I hope that doesn't start a trend, but I'm going to pause and ask for the people who joined us here today if there are any questions about HDF5, the use of HDF5 in your application. Do you have questions about how to use it, whether it's a good idea to use it? Anything? Speak up now. Or yeah, we'll pause a few more times to ask more or less the same question. Okay, if there aren't any questions, let's just go through our usual routine. Last week's highlights. Again, the HUG 2021 videos are up on YouTube. They are not just showing up; they are there. I should have corrected that. But more importantly, also, if you attended, or even if you just watched a video and something caught your attention, or raises a question or something like that, feel free to reach out to the organizing committee for the HUG events. This is a link to the email, which is hug@hdfgroup.org. And that's a good way to get in touch with us and leave some feedback. And so even if you weren't there physically or virtually, if you just watch it later, by all means, if there's something you want to ask, comment on, help to improve, just drop us a note. Forum, and I'm going to pause quickly, repeat my question. Is there anybody out there who has a question, maybe joining a few minutes late, or no? Okay, then I'll just move on. There were two new issues caught my eye. One of them was there is an error in rendering 16, so 2-byte or 16-bit floating point numbers with HDF view. And yeah, the user is basically saying, hey, I have an HDF5 file that has a data set with 16-bit floating point numbers in there, and either HDF5, I forgot already, HDF view refuses to render it or just shows garbage. And that's disappointing. And it is also disappointing for a variety of reasons. Number one, HDF5, through its very flexible data type system, has supported user-defined floating point types pretty much from day one. So back when, besides sort of exotic floating point representations like Maxis and sort of the zoo of hardware that was around when HDF5 was born, there was already the IEEE standard, which specified 32-bit and 64-bit precision floating point numbers with the standard layout, with the mantissa layout, the exponent layout, and the bias and the sign and whatnot. And that pretty much formed the basis for a user-defined floating point type in HDF5. So even back then, you could define a 16-bit or 128-bit or a 24-bit floating point type in any shape or form. And nevertheless, as you can see, and I believe the either another user confirmed that, or the person who submitted this issue reported it themselves, that the same is true for the command line tools. So h5dump, for example, also, I mean, it will show you the metadata for that data set. It will tell you that you are looking at the data set, and the type class is h5t float, and then it will probably give you some description of that floating point type, but it will not render those values correctly, it probably will just throw an error and say, I don't know what to do with it. And all I can say is another good example, and there's no shortage of those, unfortunately. It's a good example of poor execution on our part, in the sense that, yeah, if we give users these capabilities, and again, this is not new. This is not something that we introduced last year or 3 years ago. This was there 20 years ago. And so that we haven't gotten around to consistently support these capabilities that we have given to you, our users, is not good. It's not good, and there's nothing I can say other than I'm sorry for you, and I hope we can remedy that at some point. But there's no excuse for it, and it's poor execution, plain and simple. Also, it is some people might argue and say, okay, even back then, this giving users the ability to define their own floating point types was a relatively new concept. Why would you do that? Well, why would you do that? Entering GPUs. So if you look at the different actors in that space, Google, AMD, NVIDIA, they all have rekindled that interest, or maybe for the first time brought it to the forefront of many people's attention, these reduced floating point representation, whether it's float 16, AMD's FP24, TensorFloat. I think off the top of I think there are at least 4 different sort of reduced, if you wish, floating point representations specifically for GPUs. And yeah, our users have the ability to store those, if you wish, natively in HDF5, but when it comes to rendering them or looking at them, we are doing a very poor job, and there's no excuse for it, in my opinion. So yeah, I hope we can do better. What you could do as a remedy in the meantime, although I have not tried this, so let me bracket it or condition it by that. I do not know if it's possible to register what we call a soft type conversion with HDF view. Maybe that's not possible, because in certainly when you're writing user code, what you could do is the HDF5 library for its type conversions has 2 types of conversions. I think we, off the top of my head, I don't remember in which episode we covered that. They are so-called hard type conversions and soft type conversions. The difference being hard type conversions are supported by the compiler, like casting ints to floats or floats to ints or something like that. And by floats meaning the 32-bit or the 64-bit floating point numbers. But then there is also, you have the ability to register a function that does the type conversion in case either you are not satisfied with the compiler provided version, or as in this case, you basically want a conversion from a floating point type to a string representation, because that's at the end of the day what's being rendered on that grid in HDF view or in that form, let's say in H5 dump. But I'm afraid there is just no capability at the moment, no extension interface where you could register a user-defined type conversion with HDF view, and then so HDF view would pick up that type conversion and render something sensible. So I'm afraid that there's just nothing you can do, and it's really, we need to get our house in order here. Okay, I'm going to pause. Otherwise, I talk too much. Are there any questions about this specific question, about HDF view, about anything HDF5?
Garrett, I had a question.
Sure.
In the snippet of code that he showed on the forum to
Yeah.
present this example, his Python code uses numpy to,
Mm-hmm.
because it uses the as type and then it goes to numpy. What does numpy do? Because I've never used it when it encounters the 16-bit floats or these types of things.
You mean here this as type?
Yes.
Oh yeah, I think, well, this is just a casting mechanism in NumPy, because I believe the default type, so when you just call np random.random, I believe that uses single or double precision floating point numbers. So they would be float 32s or float 64s. So presumably they are float 64s, because otherwise this would be pointless. So let's assume np random.random 1010 returns a 10 by 10 array of 64-bit floating point numbers. And then you want to cast that like a cast in C. You want to cast that to 16-bit floating point numbers, with the understanding here, I believe this is just a normal no, it's a uniform distribution between 0 and 1, although don't quote me on that, but
Okay.
I think that would be a sensible default.
Okay, so then he creates that data, then he creates a dset 16.
Yeah.
Okay, using, okay.
Yeah, yeah. And H5Py probably does the right thing. It uses the HDF5 user-defined floating point, but also other data types, and just defines a floating point type, says it's going to be 2 bytes long. This is, if you search on the internet, on Wikipedia, for example, they have the exact layout. This is where the sign of that floating point number is. This is how many bits the mantissa has. This is how many bits the exponent has. And then there is what's called a bias for the exponent, where that is and how many bits. And that's it. And then it could be potentially padding. So even if this were 11 bits or something like that, that would be fine too. You would just introduce some in padding, some external padding and some in padding, and that would be all good. So HDF is perfectly capable of handling all that. But when it comes to tool support, the performance is just piss poor, as one would say.
Yes.
And,
Okay. Okay. Thank you.
Mm-hmm. Okay. Thanks. Great question. It's great to have people engaged. Another one was, and this is sort of, yeah, this blast from the past. Someone was responding to a thread that goes back to, I don't even know. Let's quickly take a look here when this was posted. May 2018. And yeah, it's again a good example of an own goal / publicity disaster that keeps biting us. And to just summarize the discussion, at the time, there was some thinking in certain circles about introducing a so-called enterprise support edition of HDF5. That went nowhere. In fact, I don't know if there ever was something that was officially called an enterprise support edition. This was also announcing the development, not announcing the release or something like that. But then, of course, this created on the forum a lot of concern and whatnot. And unfortunately, I think what got lost in that exchange was that eventually this did not happen and this did not go anywhere. And so just to be clear, and I think Elena responded to this post to the effect that there is no enterprise support edition of HDF5. It doesn't exist. And however, if you want to talk about support or consulting agreements or something like that, they are certainly available from the HDF group for enterprises, yes, but also for other organizations. So, but as a software, as a development line, as I put it here, of HDF5, meaning HDF5, the data model, the file format, and the library, there is only one, and it's available on GitHub. at this address. It's open source. It's freely available under a BSD Clause 2 license, and that's it. And so, in a way, in this sense, today it's kind of nonsensical to speak of HDF5 editions because there is only one. I'm not calling myself an edition of myself. I'm myself. And okay, so I hope that's clear, but I'm sure. I don't know if we can, it's not so much, I mean, blocking might, again, that creates suspicions of another kind potentially. I don't know if we can just, if we make that thread disappear, then some people will say, oh, this thread is being suppressed because there is some dark secret somewhere. So I guess we'll just have to live with it and periodically remind people that that was just an own goal. Like with our poor tool support, the only thing we can do is apologize and just try to convince them that there's only one HDF5, and that's it. Okay. Any questions about that, or any other questions for that matter? Okay, then I'll just move on. Today's tips, tricks, and insights. Who is afraid of H5 debug? I think we've spoken about the file format in the past, but to me, sort of whenever I prepare for these sessions, I just either pick something that's inspired by the forum, or I'm just doing a little project myself and I come across something that I think is neat and worthwhile sharing. And in this case, it was something I came across sort of going through older documents. And I found, it's linked from here, there's a nice little discussion of the HDF5 file format that was created by Quincy in 2003. And I linked it. If you go to docs.hdfgroup.org, HDF5 develop at the moment, and then look here under technical notes. It's not in its final and most beautiful and most accessible form, but here I start sort of lining up a few things that I come across that I think might be helpful for users, and including now this file format walkthrough. It was created by Quincy in May of 2003. So just for your orientation, those were the days I went back to the release notes. Again, another treat. I wish I had the time. If you go to the GitHub repository, and I'm going to divert here for a moment. In the GitHub repository, you can actually find, and I think this is one of the nice things, at least for geeks, about HDF5, that there's so much history to look back to. If you go into release docs, you can actually see the release notes starting from version 1 through, it's split up for a variety of reasons that I don't even know all. But you can start here with the history from version 1.0 to 1.80 release candidate 3, and then it's sort of broken up a little more. But so if we look at this document, it's just a text file, and you can see it starts here sort of with the first alpha version, or from the first alpha to the second alpha version of HDF5 1.0. And it's really nifty. I'm just going to sort of scroll through here, but sort of the format of the release notes actually hasn't changed much. It's just sort of, as always, what's new, what are new features, in which parts of the library or the HDF5 software were there changes, on which platforms we tested the software, and then known issues and footnotes and so forth. I'm sorry. Known problems. So what were the issues that were known at the time and so forth. So to me, this is a treasure trove. And if I had more time, or I hope one day I will have the time to mine this information, it is really, there's a lot of stuff here that help you understand how HDF5 became what it is today, with all the twists and turns and the downfalls and the shortcomings and whatnot. And it's all here. Anyway, going back, so with that, so what I did is basically look at, so Quincy wrote this document in May 2003. What were sort of the HDF versions of the day? It turns out that HDF 5.145, which appears to be the last release in the 1.4 series, that was released in February of 2003, and then HDF 5.1.60 was released in July. So May falls right in between those, and so that's the environment, if you wish, or the climate in which this document was produced. And so what Quincy does in here is, just to sort of give you a quick walkthrough, and then I invite you to try it for yourself. He says here that, okay, so the target audience for this document are current HDF5 library designers, knowledgeable external developers. I've yet to meet a non-knowledgeable external developer, but okay. And there's a reference here to the file format specification. And what he does is basically he takes two simple examples at the end of which he shows you how the primitives or the objects that you create in these two example programs are then represented in the file format. And you can explore, and to explore that, you use this H5 debug tool, which is included with HDF5. So if you build the HDF5 library and then look in the bin directory, there's H5ls, there's H5 dump and so forth, including also H5 debug. And so the first example that he examines is, I should delete that double include here, or he has probably an include assert.h missing. I should correct that. But we are basically creating an empty file in the sense that there's just going to be a root group in that file. And the file is called example 1.h5. And then this is sort of a graphical rendering. But when you run h5 debug example 1.h5, this is the output that you get from example 1.h5. It basically gives you, it tries to read the super block. There are certain file access flags. Okay, the reference count is 0, or it was actually 1 at that time. Where the super block is located. So in case there is a user block, which in this case there isn't, because we are just creating a file with a root group, what the size of the offsets are in the file. So they would be unsigned 64-bit integers, and likewise sizes would be specified as unsigned 64-bit integers. Then how the B trees are constructed, what sort of the spread is. Then there was already a file consistency flag. Off the top of my head, I can't tell you what that 3 means. What the base address is, so sometimes addresses are addresses are always specified with respect to this base address. So whenever then later in the file you read an address, you must not forget to add whatever offset is specified there to that base address. Then there was no free list or no free space management available yet, so there was no free list address. There was no, since we are using the standard POSIX driver, there's no driver information block. And then the root group. Yeah, the root group is sort of an object in the file that has an object header, but then back in that version, groups were represented sort of as two things, a B tree and a heap address that would basically store the link names for the objects that would be linked to that group, in this case the root group. Since they have names, these links have names, and those names as strings are stored on what's called a local heap or heap address. So each group has a B tree in that version had a B tree and a heap address. And this is what the root group header looks like. So for example, you would get this here, 928, according to this, the object header address of the root group is 928. So if you run h5 debug with the file name is always the first argument, but then there are additional addresses. So for example, if you want to look at an object header, let's say for a group, but also for a data set or something else, you can just specify that offset, and then h5 debug will go into the file to that offset and try to interpret what it's seeing at that address. So in this case, the superblock tells us that the object header for the root group is stored at offset 928. So if we rerun h5 debug with 928 as our starting offset, it tells us, okay, I found an object header. It gives you the version of that object header, its size in bytes. And in a way, you should read this document side by side with, I think there's a link up here, with the file format specification. So you can put two, for argument's sake, let's say this is file format version 1.0. You should have that sort of side by side with the information that you are seeing here. So that's the root group object header, and there are sort of, it has a chunked, not in the sense of data set chunks, but chunked layout, and chunk size is
Hey, Gerd, we've lost you.
that.
Hey, Gerd.
Yeah.
We lost you for maybe 10 seconds that time.
Oh, my apologies. Okay, so I was just saying, yeah, if you run h5 debug with file name and then typically an address, or sometimes an address and an offset and so forth, there are multiple arguments depending on what you are looking at. This is the kind of information that you get. So as a reminder, 928 was the object header for the root group. So if we run h5 debug with 928, then we get information about that object header, how it occupies, in this case, just one chunk. And there are two object header messages. The first one is what's called a symbol table or symbol node. And then this is just a null message. And there is another example down here. So here we are looking at the B tree and at the heap. But then down here, he has a second example where he creates a data set, just a scalar data, so a single element data set. And then you can sort of compare the output that you got from an empty, in double quotes, HDF5 file with the output from h5 debug that you get when you add a data set. So we will discover, for example, where the address is of that data set, and then we can actually see. So here is it might be the 1248, yeah. So this is where the data set is located, and then we get sort of a data set object header, and again, so it's very, I think, if you sit down and really go through it one by one, and at the same time sort of peek at the file format specification, I think this is a great way to discover things about the HDF5 file format that you might have been curious about. Always, just for the fun of it, I have the printout here. So this is actually, I just compiled it with the latest 1.13 version this morning and created, ran example 1.c and compiled it and ran it. And the structure is, so there are minor adaptations maybe to what h5 debug prints, but you see the addresses have shifted a little bit. So it pretty much matches the output from 2003, except for that the root group object header is now located at address 96. Then the B tree is located at 136 rather than 384. And the local heap shifted up It's now at 680 versus it used to be at 96. And there are probably a variety of reasons why that is the case. But long story short, and that's actually maybe an important lesson for the HDF file format understanding. It's really the file format leaves a lot of flexibility where things are actually placed in the file. So you can't really say, oh, the HDF file format from 2003 was different from the HDF file format in 2021. No, it wasn't. No, it isn't. Because I went with all the default settings and so forth. The only thing that the file format basically specifies is, well, yeah, if you give me the object header address, then I can expect to find at that object header address the header messages for the root group, for example, in this case. But the specification does not say the object header address for the root group shall always be at, I forgot what the offset was here, 928. The specification doesn't say that. So in that sense, it was 928 back then. It's 96 now. Well, except for sort of a numerical difference, it's the same thing. It's the same HDF5, and you can explore it with tools.